Today we are looking at lesson 3.1, simplifying algebraic expressions. So today's I can statements are both equations and expressions standards. I can use properties of operations to simplify algebraic expressions, and I can solve real-life problems involving expressions. So just a review of some some vocabulary that we're going to be talking about in our lesson today. You see here a addition problem, and then it says term, term, term. Those are a letter or a number or both in between plus or minus signs, really in between the addition. Those are called terms. Now sometimes you'll see them with subtraction signs, and the subtraction sign is considered part of the term, which is why on this one you can see this minus sign kind of included in the bracket below. And that's because that negative is part of the whole term. The number in front of the letter is called a coefficient, and the letter itself is called a variable. When we are looking for like terms, we need the same variable and the same exponent. All right, so for the first thing, we need to identify the terms and the like terms in each expression. So they don't want you to add or subtract anything yet. They just want a list of the terms and the like terms. So if you look at A here, we have 9x minus 2 plus 7 minus x. Okay, so we have our terms, and we need to list them out. So when I list them out, I am going to change everything to plus signs. Boom, boom. Make sure if you have subtraction, you actually make it plus negative. Don't just change it to plus. And now for my terms list, I'm going to put commas instead of plus signs. And I'm going to make sure that the 2 has a negative and the x has a negative as I write them out. So here are my terms. 9x, comma, negative 2, comma, 7, comma, negative x. Those minus signs in front of the 2 and the x are very important. They need to be considered part of the term. All right, then we need the like terms. Same variable, same exponent. All right, well, I know 9x and negative x are like terms. They are both x's. But I also know that negative 2 and 7, neither of them have a letter with them. But they are also considered like terms because they're constants. So 9x and negative x are like terms, and negative 2 and 7 are like terms. Okay, B, z squared plus 5z minus 3z squared plus c. I'm going to start by doing boom, boom. Boom, change to addition. Boom, change to sign. We don't want to forget about that negative as we make our lists. We're going to start by making our list for terms. I'm just going to write everything in the same order, but where there's a plus sign here, I'm going to write a comma. Z squared, comma, 5z, comma, negative 3, z squared, comma, z. Okay, and the like terms, again, same variable, same exponent. That was what makes something like terms. My z squareds are like terms with each other. So z squared and negative 3z squared. They both have a z and they both have a squared. And then also 5z and z. All right, so once you know what the like terms are, then they're going to want you to simplify. So we have to find the like terms, and then we have to combine the like terms. 3/4 y plus 12 minus 1/2 y minus 6. First step, boom, boom. Plus negative 1/2, y, boom, boom, plus negative 6. Now I'm going to use my commutative and associative property to reorder these and group them together with the like terms. So I'm going to start with my 3/4 y. Then I'm going to put the like term with it, negative 1/2 y. I'm going to go ahead and put parentheses around them just to kind of show that's a group I have to add. 12 plus negative 6. All right, so now I have my like terms. I have my y's together, and then I have my constants together. So I'm ready to add. I do need to make sure for the fractions I have a common denominator. I'm going to use fourths. So I'm going to multiply these by 2. All right, so now I have 3/4 y plus negative 2/4 y. Those are like terms. I'm going to keep the parentheses around them. Plus 12 plus negative 6. Okay, so now I'm all ready to combine my like terms. 3/4 y plus negative 2/4 y. 3/4 plus negative 2/4. Different signs, find the difference. 3 minus 2 is 1. More positives, the answer is positive. Denominator stays the same, 1/4 y plus 12 plus negative 6. 12 plus negative 6, different signs, find the difference. That's going to be a positive 6. So I have 1/4 y plus 6. All right, we have 4 problems here for you to try on your own. Go ahead and pause the video and try them on your own. All right, let's check our answers. So for problem number 1, first thing I need to do is list the terms. I'm going to start by doing my boom booms. I'm not going to forget about those negatives in front of the r squared and 9 as I make my list. 2r squared, comma, 7r, I'm just replacing my plus signs with commas, negative r squared, comma, negative 9, and then my like terms, two r squared and 7r. Oops, nope, not 7r. Erase that. Okay, let's try that again. 2r squared and negative r squared. And you know what? I was putting parentheses thinking I was going to have more than one set here. But I really only have that one set because I have the 7r and I have the negative 9. So that's it. All right, let's try 2. I have my terms. I'm going to do boom, boom, make that a plus negative 5. I'm going to make sure I remember to put the negative when I list that number 5. 7, 4p, negative 5, p, 2q. All right, and then my like terms. Okay, so let's see. My constants are going to be like terms, 7 and negative 5. And let's see, 4p and p. 2q does not have anything to be a like term with. All right, and then 3 and 4 simplify the expression. This is where they actually want you to combine the like terms. So 14 minus 3z plus 8 plus z. Boom, change to addition. Boom, change to sign. 14 plus negative 3z plus 8 plus z. Okay, let's see. I'm going to use the commutative property to flip-flop these two so I have my like terms together. So 14 plus 8 plus negative 3z. Don't forget about that negative that goes with the 3z. Plus z. That's commutative property. To change the order, I'm going to go ahead and put in parentheses to group them. Okay, 14 plus 8, that's going to be 22. Negative 3z plus z, if you want to write a 1 in there, you can. Negative 3 plus positive 1, different signs, find the difference. That's going to be negative 2. Z. Okay, another way to write it would be this, 22 minus 2z. When you see answers from the book, they never will write a plus negative in an answer. They will just write the minus sign instead of the negative. Either way is okay. All right, and then number 4, 3/8 b minus 3/4 b. Boom, change to addition. Boom, change the sign. I need to find a common denominator. I'm going to use 8ths, which means I'm going to multiply the 3/4 by 2 over 2. So I have 3/8 b plus negative 6/8. Negative 3 times 2 is negative 6. 4 times 2 is 8b. Different signs, find the difference. I have my common denominator now. Negative 6 plus positive 3 is negative 3/8b. All right, so now we're going to move on and talk about distributive property. We've mentioned this property a couple times so far already this year, but this is our first time practicing with it. When you see a number in front of parentheses like you do here, a 3 in front of a parentheses, that means 3 times whatever's inside the parentheses. So the pictures here on the top represent a situation. So I'm going to go to Taco Bell and I have 3 people in my family, so I'm going to order 3 combo meals. In each combo meal, you get 2 tacos and you get a drink. So if I buy 3 of those combo meals, I'm going to get a total of 6 tacos, and I'm going to get a total of 3 drinks. The same is true if I use letters T for taco and D for drinks. 3 times 2T, remember 2 means how many? 2 tacos. So 3 times 2 tacos, well 3 times 2 is 6. I can multiply your coefficients. And then 3 times my drinks, D just means 1 drink. And again, if you see something like that and you want to put the 1 in there, you certainly can. 3 times 1 is 3, so I have 6 tacos, 6T, plus 3 drinks. The number in front of parentheses needs to get multiplied by everything inside the parentheses. That's the distributive property. All right, so let's talk about distributive property with another food situation. This time it's baking a cake. So we have E representing our eggs, B representing our number of cake mix boxes, and T representing the number of teaspoons of oil. All right, so the single recipe, I need 3 eggs, I need 1 box, and I need 2 teaspoons of oil. So if I don't have a number in front of parentheses, that's just, I don't have any multiplying to do. Here they have a 1 to show you it's a single batch. 3 eggs, 1 box, 2 teaspoons. And if I multiply 1 times 3, 1 times 1, 1 times 2, I still get 3, 1, and 2. I can't actually add those together. I can't say 3 eggs plus 1 box of cake mix equals 4 egg mixes. They're separate things, they're separate variables, so I can't combine them. Okay, so single batch represents in words, there's a blank down here I need to fill in. 3 eggs, 1 box of mix, and 2 teaspoons oil. That's in 1 batch. Okay, but distributive property helps me figure out how much I would need if I am going to make more than 1. So let's say I want to double that recipe because I want to make a cake that has 2 layers to it. So I need 2 of the single batches. I'm going to put the 2 in front of the parentheses, and then I have my different terms inside the parentheses. So that 2 needs to be multiplied by each thing inside of it, because I can't just double the eggs and think I'm going to have enough to make a whole second cake. I have to double the eggs, I need to double the mix, and I need to double the amount of teaspoons of oil. Otherwise my cake's not going to turn out very well. Okay, so on my double batch, when I multiply the 2 times the 3, now I'm going to erase what I've written so I can just write it for each step as I go. Okay, so I'm going to start by doing 2 times 3. That's going to be 6 eggs total. So here I have 6 eggs. Now I'm going to do the 2 times the 1 box mix. 2 times 1 is 2. So I'm going to have 2 boxes of mix that I need. And then I need to do 2 times my 2 teaspoons of oil. So here's my spoon. That means I'm going to need 4 teaspoons of oil. So my eggs, I'm going to need 6. My boxes I'm going to need are 2. And my teaspoons of oil are going to be 4. Okay. And then here it says distributing is, and we're going to write multiplying. The number in front of parentheses by everything in our parentheses. Okay, and then it says write an expression with parentheses that represents a triple batch and then distribute to show the total quantities. Okay, so my triple batch would be 3 times, and then these things that are on the inside, this is my eggs, my box, my mix. So 3 times 3 eggs, I'm going to use E here instead of my picture, and 1 box, so I'm just going to write B for the box, and then 2 teaspoons, so I'm going to do 2T. Then I need to multiply to show if I wanted to make 3 cakes because I'm really, really hungry, how much of everything I would need. Well, let's see, 3 times 3E would be 9E. I need 9 eggs. 3 times the boxes, I would need 3 boxes of cake mix. And then 3 times my 2 teaspoons is going to give me 6 teaspoons. All right, so distributive property, here's kind of the algebraic way to see it. You might see in your textbook, A times the quantity B plus C means A times B, AB, plus A times C, AC. That's the distributive property, taking that number in front of the parentheses, multiplying by everything inside the parentheses. And when you see 2 letters written next to each other like that, that just means multiplication. Okay, so here it says, next we are preparing a recipe that requires 5 frozen bananas per batch plus an unknown amount of chocolate. And we're going to call that chocolate X. Write an expression with the parentheses that represents a quadruple recipe. Quadruple means times 4. So my 4 is going to go on the outside. All right, I'm going to write 5B for my bananas plus X amount of chocolate. Okay, so that's my expression that represents a quadruple recipe here. Okay, so that would work for any value for X. So now we're going to simplify our expression. It says write the quadruple in the bowl. So 4 batches of 5 bananas. 4 times 5 would be 20. So I'm going to have 20 bananas. A lot of bananas. Plus, and then I need 4 times whatever X amount of chocolate it is. So 4X plus 4X. Okay, and then over here on the side, there's kind of a side note. So it says when distributing a negative, which we're going to look at in our next section, our next lesson, we'll be looking at some problems that will have negatives with it. So when you are distributing a negative, we are going to multiply by -1. Okay. So distributing a negative, here we have a -2 that we're going to multiply by. Okay. I'm going to go ahead and do a boom boom in here. Try to write it neatly. Okay, that's now a -5. -2 times X is -2X. plus. Negative 2 times negative 5 is a positive 10. That sign is changing here. The positives become negatives, the negatives become positive. All right, so when I just have a negative like this, all by itself, no other number, I need to multiply by negative 1, and you can write in that invisible 1 if it's going to help you. So negative 1. Negative 1 times 4e would be negative 4e. Negative 1 times 3 would be a negative 3. So I can write negative 4e plus negative 3. Or I could write that as negative 4e minus 3. Your book won't write it as a plus negative. They'll just write it as a minus. But either way is perfectly acceptable. All right, so let's go ahead and take a look at our next one here. So simplify negative 1/2 times the quantity 6n plus 4 plus 2n. So this is another distributive property problem. We're going to multiply. And if you think about order of operations, we need to do parentheses first. We can't combine anything in here. Multiplication second, and then addition third. So we're going to save that plus 2n for the end. Times negative 1/2 is like dividing by negative 2. So I'll do some work off to the side to kind of support what I'm doing. But multiplying by negative 1/2 is like dividing by negative 2. All right, so off to the side here, just to show my work, I'm going to show you negative 1/2 times 6 over 1. Instead of just 6, I'm going to write it as 6 over 1. Okay, well, if I want to multiply straight by across, negative 1 times 6 is negative 6. 2 times 1 is 2. Negative 6 divided by 2 is negative 3. So negative 1/2 times 6n is going to be negative 3n plus. Now I'm going to do my 1/2 times my 4. Negative 1/2 times 4. And again, over 1, because when we're multiplying with fractions, you need to change any whole numbers into impropers. Negative 1 times 4 is negative 4. 2 times 1 is 2. Negative 4 divided by 2 is negative 2. All right. So that didn't have a letter with it. It's just going to be negative 2. Okay, and then I'm going to write plus 2n. All right, so, oops, I said I was going to write just negative 2, and I wrote an n with it. Got to be very, very careful when you're writing to make sure that you're keeping track of what your terms are, particularly when you are doing extra work off to the side like I did. Okay, this was a negative 2. All right, so here we go. Negative 3n plus negative 2 plus 2n. I'm going to use that commutative property to put my like terms next to each other. And I'm going to go ahead and use associative property, even though I don't have to group them, just so you can see these two are going to go together. Okay, so 3n, negative 3n plus 2n. Different signs, find the difference. 3 minus 2 is 1, so that's going to be negative 1n plus a negative 2. Or you could write it negative n minus 2. This will be how the book shows it. So that's my answer, either negative n plus negative 2 or negative n minus 2. All right, let's try these together. So for this next one, I have 3 times the quantity q plus 1 minus 4. So 3 times q, 3 times 1 minus 4. Okay, let's see. 3 times q is 3q. 3 times 1 is 3. Minus 4. I'm going to go ahead and do boom, boom. And I'm just going to throw in my associative property here, group my like terms. I'm going to end up getting 3q plus, different signs find the difference, 3 plus -4 is -1. 3q plus -1 or 3q minus 1. Okay, go ahead and pause the video and try number 8 on your own. Okay, let's check our answers for number 8. -2 times g is going to be -2g. -2 times 4 is going to be -8. Then I have this plus 7g. All right, I'm going to use my commutative property to get my like terms next to each other. -2g plus 7g plus -8. Associative property to group them. -2 plus +7, different signs, find the difference. That's going to be 5g, more positives, the answer is positive, plus -8, or 5g minus 8. You don't have to write it both ways. I'm just writing it both ways so you can see those two things mean the same thing. All right, and then let's go ahead and try number 9 together. So I have 7 minus 4 times the quantity 3/4 x minus 1/4. Don't let those fractions scare you. We're just going to multiply like we did on our last slide. Boom, change to addition. Boom, change the sign. That's like a -4 that we're going to be multiplying by. All right, we're going to ignore the 7 for right now because we need to do multiplication before we can do addition. Okay, -4 times 3/4. I'm going to do it down here. -4 over 1 times a positive 3/4. I do like to cross cancel, which I haven't shown you today. So I'm going to go ahead and cross cancel. -4 divided by 4 is -1. 4 divided by 4 is 1. -1 times 3 is -3. So when I come back up here, I'm going to write 7 plus -3x. I don't want to forget about that x. Boom, boom, that's a -1/4. I'm going to go -4 over 1 times -1 over 4. Those two are reciprocals. Hopefully you can see it. The 4's can cross cancel, the 1's can cross cancel. So we're left with a positive 1. Okay, so now I need to reorder them with my like terms together. So I'm going to do 7 plus 1 plus -3x. Commutative property to reorder, associative property to group. 7 plus 1 is 8 plus -3x. Or I can write it as 8 minus 3x. And I could have flip-flopped that too. I could have written the -3x part first, -3x plus 8, and that would mean the same thing. Okay, and then for our last type of problem here, looking at a story problem situation. Each person in a group buys a ticket, a medium drink, and a large popcorn. Write an expression in simplest form that represents the amount of money the group spends at the movies and interpret the expression. So they're asking us to do two things. First thing, write an expression. Whoa, that was crazy. And 2, we need to interpret, which means explain. Explain what it means. Okay, so those are the two things we need to do. So we're going to start with our expression. All right, so each person, I'm going to use the letter P to stand for the people. We need a ticket, a medium drink, and a large pumpkin. Okay, so the tickets are $7.50. So I'm going to write $7.50 P. Each person has to pay $7.50 for our tickets. Plus, each person is buying a medium drink, and that costs $2.75. So $2.75 per person, P. Plus, that large popcorn is our last one. Looks like that costs $4. All right, so now we need to do simplest form because it didn't just say write an expression. It did say that we need to do simplest form, which means combine the like terms. I've got some decimals, so I'm going to rewrite the number part. And I'm going to go ahead and just do all three numbers at once. You could do two at a time if you'd prefer. 0 plus 5 plus 0 is 5. 5 plus 7 plus 0 is 12. I do need to bring down my decimal. Okay, so 1 plus 7 is 8. Plus 2 is 10. Plus 4 is 14. Okay, so my expression is going to be 1425p. Story problems need a label, so I'm going to go ahead and put that $sign in there. So that's part 1. That's my simplified expression. Part 2 says explain, interpret the expression. So what does that mean? Each person will pay $14.25.